Hi, you are welcome. In this video, I'll be teaching you how you can use an inclined plane to find the coefficient of static friction. An inclined plane is a kind of simple machine that is used to move objects from a lower ground to a higher plane. We can find an inclined plane with a block moving from point O to point A. Three forces tends to act on the block. One of the force is a force that tends to push the block from point O to point A, and that force is called limiting frictional force. It is called limiting frictional force because friction tends to exist between the block and the plane. Another force we are considering is the weight of the block that tends to act downwards. According to Newton's first law of motion, in every action there is equal and opposite reaction. In this case, the normal reaction acts upwards, which is R. You must observe, however, that your normal reaction R and your weight W are inclined at an angle theta. In finding the coefficient of static friction, we resolve the forces along the plane and perpendicular to the plane. In resolving along the plane, we consider the weights and the force. The force can be resolved backwards with the broken lines. Then a right angle triangle is formed. The force and the weight are being considered. We recall SOHCAHTOA. In that case, sin theta will be used. Sin theta is equal to opposite over hypotenuse. The opposite is the force and the hypotenuse is the weight, making F the subject of the formula. We then have force is equal to W sin theta. We'll call this equation 1. Resolving perpendicular to the plane, we'll consider the normal reaction and the weight. The normal reaction can be resolved downwards, and again we have a right angle triangle. In this case, we have our adjacent and our hypotenuse, so we consider using cos theta. So our adjacent is R and the hypotenuse is W, so making R the subject of the formula, we then have R becomes W cos theta. We'll call this equation 2. Dividing equation 1 by 2, recall our equation 1 as force is equal W sin theta, and recall equation 2 as R is equal to W cos theta. So if we divide equation 1 by 2, we have force over R give us W sin theta over W cos theta. The weights will cancel the weights, so we then have sin theta over cos theta. From trig identity, sine over cos will give you tan, and by definition, force over normal reaction is defined as the coefficient of static friction. To that end, we then have mu as tan theta, that is coefficient of static friction as tan theta. Thank you. Please like and subscribe our video.